Thank you for joining this webinar. I'll give a presentation today on epoxy resins and curing agents for floorings and high-performance coatings. I'll start with the flooring applications. As you all know, flooring is a very popular application when it comes to epoxy resins and curing agents. Epoxy floorings are used in industrial warehouses. They're used in manufacturing units. They're used in hospitals, schools, colleges, and also there's a segment for terrazzo floorings. When we talk about epoxy floorings, typically what customers are talking about is a mixed layer of epoxy resins and curing agents. There are multiple layers in an epoxy flooring. There's a primer, there's a screed, and there's a top coat. Each layer has a different function, and I'll talk about that a little bit. The substrate is typically concrete, wood, or steel. For epoxy flooring, there are certain properties that everyone is looking for. The first one being durability. This is resistance to abrasion and impact. A seamless finish, both smooth and non-porous surface. Aesthetic versatility, different colors and textures. Chemical resistance, especially when we talk about industrial floorings, people may be looking for resistance to certain chemicals, oils, solvents. I'll start with the first layer, which is one of the most important layers in an epoxy flooring, which is the primer. For the primer, the main purpose is good adhesion to the substrate and also to the subsequent layers that come on top of it. The primer should seal the porous substrate and to form a solid base. The application process for the primer is fairly simple. It's the first and most important one is surface preparation, which is typically cleaning and grinding or blasting the surface. The primer is then laid down, which is typically like a low viscosity paint. It penetrates the surface, and customers typically would look for a cure time, which is less than 6 to 8 hours, depending on the environmental conditions. For the primer, we recommend our system, which is a water-based curing agent. Cam Coat is for the epoxy resin and Cam Cure is for the curing agent. And I would like to talk more in detail about the curing agent and what kind of properties this would give. So as I mentioned earlier, Cam Cure W287, this is a water-based product. It gives excellent adhesion to green concrete. It is a zero VOC product and it's very fast drying. The product specs are up here, but there's also an image of the product. It's a light pale yellow. When we talk about the features that this product would provide, it's a very easy mix ratio. So if you're talking about a basic liquid resin, which is 2071, it's 100 is to 125 parts mix ratio, which is very convenient. It's a very good mixed viscosity, which is medium viscosity, and it provides great porosity into the concrete substrate. The typical guideline formulation for this kind of product is that you would have the resin, the curing agent, and then you would add water to it in addition to the water which is already present in the curing agent. And it gives a very, very good drying to the entire system. As you can see, the surface drying is only 1 hour. The touch dry is 3 hours and a hard dry within 4 hours. It gives excellent adhesion to green concrete with very, very quick and fast drying. We've also tested the system at different levels of water. As you can see, there are 3 systems put up here with water as 1:1 to the resin, and then 1:1.5, and then 1:2. And you will notice that the drying properties remain the same, irrespective of how much water you add. When we talk about the mixed properties, you will see that the main difference is in the gel time, which in the first system is 38 minutes and can go up to 80 minutes in a system which has more water. So essentially, this system is very good for a primer. It has very good drying properties, even with increased water dosage. and one can play around with the working time of the system by adjusting the water that you put into the system. I will move on to the second layer, which is probably the most important layer in an epoxy floor, which is the screed or the mortar. The main purpose of a screed is to provide thickness and strength to the floor. It is mostly used in very heavy traffic areas. There are two types of screeds. It could be a self-leveling screed, which can be just poured onto the surface and it would self-level, or it could be applied by a trowel for thicker and heavy-duty applications. The application process for a screed, one has to mix the epoxy resin and curing agent, but then you would also have a lot of fillers in a screed, which also needs to be filled in together. This would increase the density of the product and make it very thick. The application of the screed can be either self-level or through a trowel, and the thickness can be from 2 mm all the way up to 10 mm. And the thickness depends really on the amount of traffic that the floor would have. The drying time of a screed should be less than 24 hours, but typically most people would want an overnight cure. Our recommendation for the screed is a low viscosity resin, which is Camco 2131. But more importantly, it's the curing agent, which is CamCure 2979. And I'll talk more in detail about the properties. As you can see here, CamCure 2979, it's a pretty dark colored product. It's reddish brown in color, but it has a very low viscosity. It gives excellent adhesion both to the primer as well as to the top coat, and also provides good chemical resistance properties. I'll talk about the system's features. So we've tested it both with a basic liquid resin, which is 2071, as well as a low viscosity resin, which is 2131. The mix ratio is pretty consistent. It's about 50 parts, whether you use both the systems. When you use the low viscosity system, the mix ratio can fall a little bit, but it's not very dependent on the mix ratio. It can still be used in 50 parts. What you will notice here is that the gel time can vary quite considerably, and you can have a very different level of mixed viscosity, which can impact your filler loading. You can add a lot of filler into the system based on the type of mixed viscosity you get. We've also checked the surface drying properties, and you will notice that it's a very quick dry system within 1 to 2 hours when used with a basic liquid resin, or 3 to 4 hours when used with a low viscosity resin. And it can give a hard dry in 15 to 18 hours or 22 to 24 hours, which is very much desirable for a screed. And also the surety is very high, showing that it is a very hard system and would provide the strength required. We've also done a test to see how the filler dosage can impact the epoxy screen. In the first image, you will notice that the resin is to hardener is to filler is in a ratio of 2 is to 1 is to 3, which is essentially saying that there's one part of epoxy resin system and one part of filler in equal parts. But then we checked this, and this image is showing the self-level properties of the screen. In the second image, you will notice that we have added 33% more filler, and the system still remains to be a self-level system. In the third image, we have added 67% filler, and it continues to be a self-level system. And in the fourth image, we've added double the filler that was there in the first image, but it still remains to be a self-level system. So this is a very, very good system which can have a very wide range of filler dosage and still give you a self-level sort of a screen. Moving to the top coat, which is the most important coat when it comes to a epoxy floor, the purpose of this is both protective as well as decorative. The second is to provide resistance to chemicals, to provide abrasion resistance, as well as exposure to UV light, but from an indoor point of view. The application process for a top coat, one has to mix the resin and hardener. There could be some optional additives and things that can be put into the top coat, such as anti-slip additives or other things, as well as decorative flakes. The application is typically by a roller, or it could also be sprayed with multi-layer films. And the drying should be typically between 1 to 2 days. I would say it's more or less than 1 day. In this situation, we recommend three different systems. And the reason for that is that each system would provide a different sort of end property. The first system, which is with CamCure 2810, this is an amine blush resistant system. The second one, which is CamCure 2416, this is the general purpose top coat, which also gives good all-round chemical resistance. And the third system is CamCure 2965, which is very good for low temperature cures. And I will talk about each of these systems one by one. When we talk about CamCure 2810, as you can see from the image, it's a very, very light, pale yellow curing agent. It gives excellent amine blush resistance. It's a very light color and has great color stability. And it also gives very good mechanical properties. I'll talk about the details about this system. As you can see, the mix ratio is very convenient with a basic liquid resin 2071. It's a 100:40 parts mix ratio. We've also created panels to check how is the amine blush. While this image doesn't do justice, I can tell you that typical cycloaliphatic hardeners could have some amine blush on their surface. 2810 on the other hand has absolutely no amine blush and is a very good system when customers are concerned about that. Moving to the second system, which is CamCure 2416, this is a good all-round chemical resistant system. As you can see from the image, it's a water white color curing agent. And that is very, very important for a cycloaliphatic hardener, which can be used even for clear coats. This system gives very good chemical resistance, and I will talk more about that in my later slides. So talking about 2416, it's a 100:60 parts mix ratio, which is very convenient for a top coat. It gives a thin film set time of just 7 hours. So as I mentioned earlier, customers are typically interested in a cure which is less than 1 day. In this particular case, it's a thin film set time of 7 hours, which is very, very convenient. From these images, you can see that even when you create a clear, unpigmented top coat with 2416, it is completely clear. And in this case, we have created that on a steel panel. The other two images on the right-hand side, the first one is for a typical cycloaliphatic, and the one on the right is for 2416. It gives a very smooth, glossy top coat finish. I'll talk a little bit about the chemical resistance. We've checked chemical resistance for a lot of different chemicals, and that data is available with us for anyone who wants to know. Here I'm going to show some images for a few different tests that we've done. The first one is for nitric acid, which everyone knows is a very harsh sort of an acid. We've created panels on steel with a clear coat of basic liquid resin 2071 with CamCure 2416. You will notice that we have done the test at two different durations. The first one on the left is for 5 hours, and the second one on the right is for 24 hours. And even with 50% nitric acid concentration, you will observe that there is only minor discoloration in the film. There are no film defects or any kind of destruction on the film. We have also done salt spray tests. And similar to the previous slide, what we've done here is that we've checked it both with basic liquid resin and we've also checked it with a Novolac resin. Camcoat EPN 1154 is a Novolac resin, and I'll talk a bit about that resin in my later part of the presentation. But you will notice that in the first one, which is with basic liquid resin, we checked it after 500 hours, and with the Novolac resin, we checked it after 750 hours. And in both cases, there are no blisters, no corrosion, and no creepage observed. So this is a very good system for good all-round chemical resistance. Coming to the third system for the top coat, that's CamCure 2965. This system is very good for low temperature cures. It's also a very good system for chemical resistance. This system can be used in a very convenient mix ratio of 100 is to 50 parts when it comes to basic liquid resin. And you will notice here that the thin film set time is only 4 hours as compared to 7 hours for 2416. The mechanical properties for the system are also very good. The compressive strength, the tensile strength, and the flexural strength are very high. And the surface drying properties we have checked at 25 degrees as well as 15 degrees. And you will notice that even at 15 degrees, the surface dry time is 3 hours, the tack-free time is about 5 to 6 hours, and a hard dry time is about 12 hours, which is very, very convenient even in cold temperatures. We have also checked the same system for nitric acid, just as we had done for 2416. And you will notice from the data and the images that even this system can withstand nitric acid after 5 hours and 24 hours with just a little bit of discoloration. There is no destruction to the film. And similarly, we have also checked it for salt spray resistance, both with basic liquid resin, which is 2071, as well as Novolac resin, which is Camcoat EPN 1154. And you will notice that in both cases, with basic liquid resin at 500 hours, as well as Novolac resin for 750 hours, there is no corrosion, no blister or creepage. Moving on with flooring. So just to summarize, I spoke about primers, I spoke about screed, and I spoke about top coats. In the primer, what I've recommended is a water-based because it gives very good penetration and bonding to green concrete. For a screed, I spoke about a system which is very good for self-level and can be added with a lot of fillers and remain to be self-level. And for the top coat, I spoke about three different systems. The first one for amine blush, the second one as a general purpose system, and the third one as a low temperature cure system. Now, what I'm going to talk about briefly is the type of testing that people would like to do on a flooring. The first and most common test is a pull-off adhesion test to ensure that the flooring is well bonded to the substrate. The second type of test is a chemical resistance test. And in this case, we are just showing a test which is a drop test with the chemical staying in a small surface area. But one can do various types of chemical resistance tests and even cyclic corrosion tests, which are very much possible. The third type of test is an impact resistance test, which can be for various types of mechanical properties. The fourth test is for the hardness, which is typically for surety. And the fifth type of test is for abrasion. These are the most popular tests that people do for epoxy floorings. So with this, I have completed the first part of my presentation. I'll move on to the second part, which is about industrial and protective coatings. The typical applications in this area are industrial and protective coatings, which could be for pipes and chemical structures. Then there are specific coatings, which are pipeline coatings. Then there are linings. Linings are typically for tanks, but could also be for other chemical structures. And then there is marine coatings. I will talk about a few different systems for these applications. When we talk about industrial and protective coatings, we are looking at a few different things. The first and most important is protection, which could also include just general environmental degradation of a coating. The second is the durability of the substrate, and the third is the aesthetic performance. The most important properties are corrosion resistance, chemical resistance, abrasion resistance, UV and weather resistance, and also thermal protection in some cases. Protective coatings are typically applied. The process is the first is the surface preparation, which is the most important process. The second being the application of the primer. The third would be intermediate layers in some cases. Then there would be a top coat, and then there could be different cure schedules that get used for curing these systems. I'm going to talk about a few recommendations that we have and the reasons for it. The first is for a primer or an intermediate coat. I will talk about one system, which is a basic liquid resin, Camcoat 2071 with CamCure 9054. For the top coat, I'm going to talk about two different resins, which is Camcoat 2071 as a basic liquid resin, and also the Novolac resin, which I have covered in the earlier part of my flooring application. On the hardener side, I'm going to talk about three different hardeners because they give slightly different properties. So coming to the first resin, which is Camcoat EPN 1154. This is the Novolac resin. It's a very high performance resin. It gives outstanding chemical resistance. It gives excellent heat resistance as well as resistance to a lot of chemicals, including solvents. And this resin can be used with a wide variety of curing agents. Also, another thing I should add here is that unlike most Novolac resins, this is a liquid at room temperature. Coming to the first curing agent, which is CamCure 9054, which is very good for primers as well as intermediate coats. This is a low viscosity product. It gives excellent adhesion, and that's the reason this is typically recommended when it comes to primers. In terms of chemistry, this is the Polyamidoamine chemistry, and it continues to be a very low viscosity product, unlike many other polyamides or amidoamine products. Pairing a primer system with CamCure 9054 and CamCoat 2071, which is the basic liquid resin, it's a very convenient mix ratio of 100:50. And you will notice that the gel time is about 1.5 hours, which is very, very convenient. The peak exotherm is only 50 degrees, which is extremely important because this would ensure that the system does not have any heating at the time of application, and it gives a very good surety and compressive strength. Coming to a top coat, I had recommended three top coats. I'll talk about the first one, which is CamCure 2280. This is an excellent product for chemical resistance. It is very low viscosity and can also be used for low temperature cures. We have done all sorts of chemical tests on it, and I'll talk about the first one, which is with the Novolac 1154. And we did a test with sulfuric acid as well as hydrochloric acid. And as we know, both of these acids are very strong. You will notice an initial panel which is pigmented. And on the left-hand side, you've got 50% hydrochloric acid after 30 days. And on the right-hand side, you've got 70% sulfuric acid after 30 days. And you will notice that there is only slight discoloration in the film, and there are no defects of any kind, which goes to show that this system is actually a very, very good product when we want very high acid resistance. Similarly, we have also checked the system for acetic acid and sodium hydroxide. On the left, you've got the system, which is with sodium hydroxide, and on the right, you've got the system with acetic acid. Now, when we check this after 30 days, there is a 50% solution of sodium hydroxide or a 10% solution of acetic acid. And you will notice there is only slight discoloration in the film. There are no defects or any kind of destruction to the film even after 30 days. Moving on to the next product, which is CamCure 2969. And as you can see right away, it's a very, very dark product. It is brown to black in color. However, this is an aromatic product, and being aromatic chemistry, this provides excellent chemical resistance. Probably the best in class when it comes to chemical resistance. It's a low viscosity product and it has a very convenient cure schedule. Now we have checked the system with both Novolacs as well as basic liquid resin, but you will notice right away that it's a very convenient mix ratio of 100:60 parts. It has a gel time of about 2 hours, which is very convenient. And also in this case, the peak exotherm is only 55 degrees, which is very, very convenient. And it gives a surety of 80 and compressive strength of 110. So this system is very good for compressive and mechanical properties as well. We have checked this for various kinds of chemicals and resistance. The first one being salt spray. And you will notice that the panel on the left is the initial panel, and the panel on the right is after 750 hours. And this is not with a Novolac, but a simple basic liquid resin. And even after 750 hours, there is no blister, no corrosion or creepage to the film, which goes to show that Camcure 2969 is probably the best in class when it comes to general purpose chemical resistance with basic liquid epoxy resins, and there is no need for Novolacs. The third and last product I'll talk about is Camcure 2965. You will notice that I've already spoken about this product in my earlier section, which was on floorings. So I'll quickly go through this. This is very good even for chemical resistance and protective coatings. And I've already run through this details about the mechanical and the chemical properties about this product, both for nitric acid as well as the salt spray. So that was a quick presentation from my side covering the floorings as well as the protective coatings products. Thank you very much.
Thank you, Gaurav, for a very interesting and comprehensive presentation. I can see that we have a number of questions already sent to us, so we'll get started with those, shall we?
Yes, please.
Okay, so the first one is from Abdelrahman Mohammed. Can we use the water-based epoxies in screeds?
You can use water-based epoxies for all the three layers actually. You can use them for the primer as I have recommended. It can also be used in the screed and the top coat. The main reason I recommend this for the primer is because the water-based gives a very good penetration and adhesion to green concrete. And that is the standout property about a water-based. However, if you have a need to use it in the screed or a top coat, you can go ahead and do it.
Okay, perfect. Thank you. Another question from the same attendee. So if we were to use a 2:10 ratio of epoxy to filler in the screed system, would it provide a higher film thickness and also better self-leveling properties?
So what is going to happen is when you increase the filler dosage in the screed, the density of the product will keep increasing. And that will make it harder and harder to make it self-level. The system which I've shown is a self-level even when the epoxy and curing agent is in a ratio of 2:1 and the filler is going up to 6 parts. So essentially the epoxy to filler is in a ratio of 1:2 and it's still self-level. But if you go for a higher dosage of filler, it will become harder to make it self-level.
Okay, thank you. We have another question from Mohammed El Achouri. Apologies if I've not pronounced that correctly. Has there been any testing done on the flammability of these coatings? And that was sent in while we were talking about the flooring coatings.
We have not checked it directly for flammability, but if there is a need to that, I can have it checked in detail with my R&D center and we can do those tests and get back to you.
Okay, thank you very much. We have a few questions now from Richard D'Souza. So again, when we were talking about the flooring coatings, in the water-based primer, the drying time is mentioned. Was that at ambient temperature?
Yes. So all of our testing is done at 25 degrees Celsius. So typically all the data you'd see is for that temperature. However, we do also test at lower and higher temperatures, and that data can be available with us if you need it.
Thank you very much. Second question from Richard. So when you talk about the Camcure 2979, is this a phenalkylamine?
No, this is not a phenalkylamine. It is actually a blend between an aromatic and a cycloaliphatic product. So it's something that we have developed in-house. It is not a phenylcamine chemistry.
Okay, thank you. And then the final one from Richard. Do you have any data on the compressive strengths on the combinations you spoke about for the screed?
Yes. So we would have mechanical property data for pretty much every curing agent that we make. We would check the compressive, the tensile, and the flexural for all of our products. And that can be provided to you with a wide combination of resins. Normally, in our data sheets, you will find data which is for basic liquid resin. In our case, the number is 2071. However, if you need it for a different resin, we can also do that and give it to you.
Okay, so Richard, can I suggest you maybe get in contact with Champion directly on the email that you can see on the screen, if there's anything specific you wanted to answer. Okay, so we have a question from an Alfredo Garcia. When you talk about the acid tests on the images, there is yellow spotting. What happens after these spots?
So this is just a discoloration. The images we showed are for 24 hours. And the reason we have some tests which are done at 24 hours and some which are going on for 30 days is because when you're doing flooring, you might have an acid which drops on the floor and then it gets cleaned up. So if you have an industrial floor, let's say it's a manufacturing site and there is someone manufacturing batteries, you'll have sulfuric acid flooring on falling on the floors, and they might stay on the floor for a few hours and then get wiped off. So what we are really trying to see is if the acid is on the floor for a few hours, how does that impact the floor? And that is the reason that the test is done up to 24 hours.
Okay,
So
thank you
if
very
it
much.
just causes some discoloration, it's not going to impact the floor in any manner.
Okay, thank you. And the next question is from a Jody Vallis. Do you have cycloaliphatic epoxy resins for direct-to-metal protective coatings?
So we do cycloaliphatic products. We also have hydrogenated bisphenol A products, which can be used for outdoors. But when it comes to direct to metal, there is not really a necessity to use any of these. You can also use basic epoxy resins. The curing agent would play a very important role in terms of providing the properties. So depending on the type of properties you want on the metal, it could be adhesion, it could be the thickness, it could be the chemical resistance. We would recommend the right system for you once we understand the application. In most of protective coatings, the actual application is on metal and epoxies would be applied directly on the metal.
Okay, thank you. The next question, again, is from Abdul Rahman Mohammed. Can the water-based primer be used on new concrete, say 10 to 15 days?
Yes. So actually water-based are highly recommended when it's green concrete or new concrete. And the reason is that the water can penetrate the concrete and provide great bonding and also close up the porosity that the concrete has.
Okay, thank you. And while we're on the subject of green concrete, there's another question. Is there any disadvantage to using a water-based primer as opposed to pure epoxy and hardener?
I wouldn't say there's any disadvantage. Obviously, when you're talking about a water-based product, or water-based curing agent specifically, when you look at the solids content, it would typically be about 50%. So you're using a curing agent which has 50% water, which is going to get absorbed by the concrete and also evaporate. So one has to basically consider the commercial viability of doing that. But in terms of performance, I don't see any disadvantage.
Okay, thank you. And then we have a question from a Mustafa Ibrahim. Can I mix bisphenol F with a water-based hardener?
So we have not tested that. I can test that and come back to you. However, my gut feeling is I don't see any reason why that would not work. We have checked it with a basic liquid epoxy resin, which is a bisphenol A product. A bisphenol F epoxy resin is essentially going to have a lower viscosity. It's going to give you low crystalline, which is something that you might want to use in the UK. So that's something we can easily test at different levels and come back to you on.
Okay. And then here's one I can answer. So Richard has asked if we'll share this PowerPoint. So yes, Richard, as an attendee, you will receive an email with a link to the presentation that you'll be able to access. And then a final one from Richard. Do you manufacture polyamides?
Yes, we do polyamides. It's a very important product line for us. We have a wide range of products. The one product that I did speak about, 9054, that's a polyamidoamine, but we have all the other polyamides to go with it, right from the low viscosity to the very high viscosity. And we do have polyamides which get used even in adhesive applications.
Okay, perfect. Well, thank you, Gaurav. That's all the questions that we've got today. So thank you again for presenting. And I'd just like to say to the attendees, if you are based in the UK and you want any further information or to discuss specific requirements, please feel free to contact me at Lake Coatings.